We are recording. Yep. Here you go. Everybody else has one, right? Don't let me forget, the three of you, that I've got the practice AP test for this weekend. I know that you're probably not going to take it, but you should still have a copy so that when we talk about it Monday, you'll have it as a reference. Okay. So, today we're talking about the last test that you might have to do, which is called a chi-squared independence test. It is for basically seeing if two things are independent from each other or if they're dependent from each other. Today we're going to be analyzing something really serious, which is is gender affect the way you like to eat ice cream? What do you guys think? Think it does? Do you think like ladies are more likely to like have a cone or a cup when it comes to ice cream? This is not a sexist topic, guys. You can't be like, yeah, I do think girls like cones better. And I'm like, how dare you? Get out of here. Don't say that about women, you know, like this is just a, do you think that it's possible? Guess it could be. What does your instincts tell you?
I think female would be cup.
Okay. Well, let's see. The males are way higher than the females with cups. Does that mean that she's right? Because why? There's way more males in this study than there are females, okay? So you can't necessarily decide that. All right, so a chi-squared independence test. What this does is it tests to see if two variables are related. This is kind of a stupid one because nobody really needs to know this information ever. But there are really important things like in science about this, like if they want to determine if somebody who drinks a lot of caffeine every day, if that's related to having heart attacks. So that's a legit thing that we should probably know, that kind of stuff. An R by C contingency table. That stands for rows and columns. It's this, that's what it is, right there. Do you guys remember that rows go left and right and columns go up and down? It shows observed frequencies for two variables. There's a lot of information in this chart right here. So why am I just saying there's only two variables in this chart? What are the two variables? What? No, that's one variable. One variable is gender. What's the other one?
It's like, yeah, so it's gender and then what is the
Right. So the this is one variable and this is one variable. Even though there's multiple options for each one, it's not just two things. This one has two choices. This one has five choices. All right. So here's the formula for finding an expected frequency for the contingency table. You take the sum of row R, you multiply it by the sum of column C, and you divide by your sample size. And this is, it says E with a sub R comma C, so it'd basically be the expected value for a certain row and column. All right, this is actually perfect that one of you is gone. I mean, I miss you desperately, Caleb, but it really worked out with the math. So I'm gonna do one with you, and then we have 9 left over to do. What? And there's 9 of you. So perfect. Okay, so I'm going to do E1, comma 1. And then we're also gonna write all the others down. I don't expect you to do the math for every single one of these. But I expect you to do the math for one of them and copy down everybody else's answers for the rest. How many videos were there yesterday? 6? Did your heart sink a little bit when you open that? You're like, 6? Ah. But each one's like 8 minutes, so it's not that big of a deal. I was thinking about you, and when I posted that, and I'm like, psh, poor guy. Open this page, see 6 links in front of him, and go, "Ugh." Which is funny, because you're probably also looking at the notes going, these don't seem that long. How did they take this long doing this? Turns out if the teacher messes up, that might have been 5 videos instead of 6, but. Okay, so these are rows and then columns. So this means first row, first column, first row, second column, first row, third column. You getting it? Up here, once you label them, cup is 1, cone is 2, sundae is 3, sandwich is 4, other is 5, male is 1, female is 2. So I'm going to take that male cup one, figure out what we should have expected to see in the male cup category. So I am going to make a fraction. I need the sum of row R. That means my row is 1 and my column is 1. So my first row, the sum of that is 1,200. I'm going to multiply that by the sum of column 1, which is 1,002. And then divide by the total, which is 2,200. Do you have to put the top in parentheses in your calculator? No, actually you don't, but if you did, it wouldn't hurt. Let's go 2 decimal places for this one. I got 546.55. You guys get the same thing? So this is basically saying, look, if I think about how many people chose cup and how many people there were in the male category, I should expect about this many people to choose of males to choose cup. This is my expected amount. I expected that about 547 males should have, but it looks like more than that did. Do you see what I mean? Okay. And since more than that did, this is starting to make me think that maybe gender has something to do with this amount. And if you're like, yeah, but maybe your sample size isn't big enough, they have 2,200 results here. That's a lot of ice cream that people ate to prove their point. So let's split up the work now and get this done. Emma, you want to do this one? Mason, you got that one. Thomas, Rihanna, Jesselyn, Sierra, Natalie, Brennan, and Caitlin. And Caleb, if you're watching this, you can just sit back and relax, or maybe try one of them. Pick your favorite one, Caleb. Which one is it going to be? Is it going to be 2-4? I feel like it's going to be 2-4. It feels like a Caleb kind of number. What's Caleb's number in baseball? 22. Ah, crap. Then he's picking this one. And it's yours, too.